All right, here's a refresher on limits at infinity, and we're going to go through this kind of quickly. What I want to do is horizontal asymptotes, you take the limit as x goes to infinity of f of x, and that would be either L or the limit as x goes to negative infinity of f of x. To find the limit, and so what I want to do is I want to show you some really quick ways to do this. All right, so, or really quick ways to think about this. So I want you to recall these graphs, and this is a way to think about this. So recall, and I'm going to look at these graphs basically from 0 to 1. And so I'm going to draw them graphs from 0 to 1. So here is one graph. Here is another graph. And here is another graph. All right, so there they are. So this is the line y equals x. This is, so how does this work? This one is y equals x squared. This is y equals x cubed. And this is y equals x to the fourth. So notice that as x gets bigger, as n gets bigger, so y equals x to the n. That doesn't look really nice. So as x gets bigger, as n gets bigger, so notice that if I look at the limit as x goes to infinity of x to the n, that is what I'm trying to say. This goes to infinity. Okay? Would everybody agree with that? That this thing right here is going to go to infinity, right? Because this is a polynomial and it's going to blow up. The point I'm trying to make is the higher the power, the faster the graph goes to infinity. Okay? So this is the first thing I want you to realize. That the higher the power, the faster the graph goes to infinity. And if you notice these graphs, the higher the power, the faster these are going to go to infinity. The second thing I want you to think about is the graph of 1 over x. So if you look at this graph, right, the limit as x goes to infinity of 1 over x, that equals the limit as x goes to infinity of 1 over x equals 0. And the limit as x goes to 0 of 1 over x does not exist. Okay? And similarly, if this is negative infinity and negative infinity, then it also equals 0. Right? Does everybody see both of those things? So if I put 1 and 2 together, so my third observation is putting 1 and 2 together, we noticed the higher the exponent, in the numerator, then the limit will go to infinity faster. The higher the exponent in denominator, then the limit will go to 0 faster. If they have the same highest exponent, then the limit is the ratio of leading coefficients. Okay? So now let's get to some examples. Where's the highest exponent? Denominator. So what's the limit? Highest exponent's in the denominator, 0, because highest exponent in denominator. Ba-dum. Okay? Where's the highest exponent? Numerator, limit does not exist because highest exponent in numerator. Same highest exponent, ratio. Okay? Now, this last one is a little more difficult. So this equals the limit as x goes to negative infinity of x to the 4th over x to the 6th minus the limit as x goes to negative infinity of 7 equals, here the first term, that should be a negative infinity, is 0 minus this term is 7, so the answer is negative 7. This is because highest exponent in denominator.